So there's electricity, very start of it, and we're going to look at current and charge. Now, you have met current before when you were in first year, and if you remember, don't worry too much if you don't, because I'm going to do it at length now. Current is a flow of electrons. Okay, now an electron is so tiny that we can't measure current in terms of number of electrons that are flowing by, because they're so tiny, but that's what's moving. Okay, now remember, the electrons are already in the wires, but current is a flow of electrons, and they're made to move because the battery shoves them. Okay, now we don't deal with electrons, we deal with groups of electrons called coulombs, but we'll come back to that in a second. Coulombs are charge, but you measure current with, and who can remember? Try and remember. Okay, ammeter. The symbol for an ammeter is two lines and an A in the middle. That's not a great diagram, but bear with me. Okay, and you connect ammeters in series, and that will make a lot of sense to you just now, but you'll see in a minute. So if you're building it, let's say you want to measure a simple circuit, you're measuring the current through a light bulb. So you put a battery, which hopefully you can all remember the symbol for a battery. I'm going to try and use a wee drawing tool here. I don't know how this will go, give that a go. There's the battery. There's a simple wee circuit. Circle, we'll call that. That's going to be a bulb. Oh, doesn't like that very much. That's an ammeter. Don't like that, okay. That's an ammeter. And there we go. Now, that's it. So what happens is, an ammeter, that's called connected in series. So that says those are connected in series. So ammeters are always connected in series. Meter, always in series. Okay, now current flows through it. Now in a battery, just in case you can't remember again, the small line is the negative and the large line is the positive. That made a mistake there, the examiner will type me for that. You've got to join it up properly. Okay, think about it as, think positively, live longer. It's the longer line. So let's write that down. It's probably true, but think positively. Live longer. Because the longer line, see this is longer here, this bit here is longer, is the positive. Anyway, electrons, if you remember, are charged negative. Now remember, like charges repel. So because it's two negatives together, that wee electron wants to go that way. That would terrible arrow, I'll try that again. Go that way. Also, electrons love to go towards positives. So there's another reason why it wants to go that way around the circuit. It loves going away from negatives and loves going towards positives. Okay, now current is measured. Current is measured in, time for a change of colour, amperes. But to be honest, we just shorten that to amps or just A. Okay, so for example, oh, one more thing I forgot to say. Symbol for current is I. So example, I equals 4, what did that wee m mean again? Milli, well done. 4 times 10 to the minus 3 amps. Okay, that's what that means. Alright. Now, we don't measure, so what we do is we are going to look at a thing called charge. Okay, so charge. And that's got a symbol Q. Alright, it's a strange thing. You'll see there's no Q in the word charge, if I can spell it correctly without a C. So charge. Okay. Electrical charge. Oops, wrong setting. Sorry. Just getting the hang of this, guys. electrical charge is measured in coulombs, or C, new page. Okay, so Q is charge measured in coulombs, which is a C. Alright, so I'll give an example, sentence example. The total charge that flowed through the bulb in 60 seconds was 10 C, 10 coulombs. Okay, I'll put it out properly. Or 10 C. Okay, now we define, so this is important, this one, so it's time for, so definition of current. Definition of current. Okay, definition of current. 1 amp equals 1 coulomb per second passing a point, or passing by. Okay, so 1 amp, I'm trying to draw a wee square around this, a different colour, let's go for blue. So 1 amp is 1 coulomb per second passing by. Right, that's an important definition. Now I'm going to write that now is, so what that means is I've got a current, to write as an equation, if a per means a forward slash, is the total charge over time. And I've jumped a wee bit ahead there, I'd probably take more time over it if we're in class, but that's the basic equation. This is called the Nike equation, because if I turn it round, if I take the Q to the left hand side, it becomes, if I take Q over here, oops, hang on, if I take Q over here and I over there, I get Q equals IT. In other words, never quit. Okay, Nike equation. Alright, so that's Q equals IT, I equals Q over T, and just for arguments, just so we can get it completed, T equals, go for it, do yourself, 5, 4, 3, 2, 1, correct, Q over T. Alright, and that's in coulombs, that's in amps, that's a C, and that's in seconds. Okay, and that's the equation you're going to be using for the questions we've set you. There's a wee tricky bit that we can do later on, but for now I'm going to call it quits. That's longer than I expected it to be, so have a go in that. And remember, currents in amps using an ammeter, measured in series, connected in series I should say, and that should get you started in that homework. Alright, so another kind of question you can get regarding charge, this is a trickier one. So the question could be, how many electrons are represented or contained by a certain amount of charge? So let's just say, for argument's sake, 3 coulombs. Okay, so it's how many electrons are represented by 3 coulombs. Because remember, a coulomb isn't actually a thing. There's not a giant big ball called a coulomb. That's not right. What you've got is billions of electrons, trillions, uncountable numbers of electrons to get that make up a coulomb, alright? Because an electron's too tiny to really do the calculations with. But really a coulomb is just a representation of lots of electrons. So here's an equation. It's not really an equation of finding the equation list, but it helps you. So you can say number of electrons equals total charge divided by the charge on one electron. It's like, imagine I gave you a wee packet of Smarties, okay, and I told you that the calorie content was 1,000 calories in there, and I said, well, one Smartie equals 10 calories. Well, how many Smarties are in there? It's 1,000. So the number of Smarties equals 1,000 divided by 10 equals 100 Smarties, right? So 1,000 calories in total in the packet. If I told you that one Smartie's got 10 calories, therefore the number of Smarties is 1,000 over 10. So here it's the same kind of idea. So it's number of electrons, the total charge, which is like your total number of calories, and the charge of one electron, which is like number of calories in one Smartie. Now, don't worry if that seems a bit strange. We'll just leave that, just put that as a bracket. If it doesn't help you, don't worry. What we'll do is we'll skip down to here, zeek, and therefore number of electrons equals 3 divided by 1.6 times 10 to the minus 19. Now that's on the data sheet, so don't worry. That's the charge on one electron, which you would sometimes see written as, in the following way, they would say E equals 1.6 times 10 to the minus 19 coulombs. Sometimes see it that way. Anyway, that's going to be a big number. Remember, electrons are tinier than the tiniest thing you can imagine, right? So let me just put my calculator here. So if we do that, so it's 3 divided by 1.6 times 10 to the minus 19 gives you, so that's 1, equals 1.875 times 10 to the 19 electrons. That's how many are represented by 3 coulombs. Okay? So it's just a number. So it's the number of electrons equals 1.875 times 10 to the 19. This isn't really an equation you'll get in the equation list. However, if you want to write it down, you might find it helpful.